All right, let's look at the limits at infinity. So here's the definition. All right, so limit of function f of x as x approaches positive infinity is equal to L. If the value of f of x can be made arbitrarily close to L, so f of x is getting closer to L, by taking x sufficiently large positive. If you're going to positive infinity, it has to be a large positive. And we can do a negative infinity too, so I'm going to just add that. So if you want x to go to negative infinity, only difference is you have to take x to be sufficiently large negative. All right, so it's basically it's talking about the tendency of the function as x gets larger and larger and larger, positive, so moving to the right hand side, or x is moving to the extreme left hand side, and they want to see what happened to the function. All right, so here, if you look at the picture here, so if you're talking about the limit of this function f, so here's f, which is in purple, and as x approaches positive infinity, right? So you can see that you can follow this graph and you're moving to the right, and as x gets larger and larger and larger, looks like the value settles around L1. So the limit is L1, right? But if you're going to x is going to negative infinity, so limit of f of x as x approaches negative infinity. All right, so you follow the curve and it's getting smaller and smaller, but you can see that it kind of start to flatten out and looks like it head toward the value L2. So the limit is L2 there. All right. So those are limits at infinity. So you have the positive n and the negative n, and those are the two kinds. All right. So let's look at the following example. See if we can find the limits at infinity. All right. So if you look at the function sine of x over x squared, so it's going to look like this. So sine function, so it goes up and down, up and down, up and down. Because it's divided by x squared, the amplitude is getting smaller and smaller, right? Same thing on the left-hand side too. Right, so in this case, you can see from the picture, right? So as x gets larger and larger, the function gets smaller and smaller and getting closer to 0. So the limit is 0. And you can see that same thing is really happening on the left-hand side as well. So the limit is 0 there. All right, it's pretty simple, eh? All right, how about this one? All right, how about arctangent? Just knowing what it looks like, it makes the world of difference. Here, arctangent. All right, so arctangent is the inverse of the tangent function and the middle piece. So it looks like this. Right? So if you're going to positive infinity, you can see that the function value is getting closer to pi over 2. So the limit here is pi over 2. Right? But if you're going to the left, so follow this, x is getting larger, negative, you can see that it heads toward negative pi over 2. So the limit is negative pi over 2. Right? So those are the simple examples of limits at infinity. All right, that's it. I hope that this was clear.